Here we're going to look at two other ways of displaying data. So far we've looked at histograms and column graphs. In this exercise, we're going to look at dot plots and stem and leaf plots. So let's concentrate on a dot plot to start off with. You might remember back in primary school drawing pictographs where you drew a picture for every value or every frequency. Well, this is what you are actually doing with this, except you're drawing dots. So a dot plot records the frequency of each category, if it's categorical data, or if it's numerical, of each value in the data set. So if we wanted to talk about the shape of the dot plot, if you have a look at this dot plot here, you will see that it looks kind of like a histogram. So we can talk about them exactly the same way. If that was a histogram, we would say that it was symmetrical. So hence, this dot plot is symmetrical. Again, if this one here was a histogram, we would say that it was positively skewed, because you can see that the tail is going to the positive direction. So when you're asked to describe a dot plot, we are thinking exactly the same way as what we would for a histogram. So let's have a look at this example here. The dot plot shows the number of goals per game scored by a team during the soccer season. So we're just going to actually answer some questions here. So let's make sure that we know what this dot plot is about. So down the bottom, we've got 0 to 7 and number of goals per game. How are we interpreting this? Well, let's have a look at the first one here. What does that mean? What do those two dots mean? Well, the number of goals per game. So what we can actually say here is that two teams scored no goals in a game during that season. Here, if we look at this one, where there are 5 dots, we can say that 5 teams scored 6 goals in a game during that season. So we must make sure that when we look at our graphs and tables, that we know exactly what the information is telling us. So how would we answer this first question? How many games were played? Well, how many games were played? How many dots are there? If you count all the dots, there are 20. So therefore, 20 games were played. What was the most common number of goals per game? So what they're really asking here is which value has the most dots, and the value that has the most dots is the 6. So therefore 6 goals in a game occurred most often. So therefore our answer here is the 6, the one with the highest frequency, if you like. How many goals were scored in the season? This requires a little bit of work. The answer is 86. Now, how did I get that? Well, let's have a look here. So 2 teams scored 0 goals. So we've got 2 times 0 plus 2 teams scored 2 goals. So 2 times 2 plus 2 teams scored 3. So it's 2 times 3 plus 3 teams scored 4 goals in a game, so 3 times 4 plus 4 teams scored 5 goals plus 5 teams scored 6 goals plus 2 teams scored 7 goals, and that is a total of 86 goals. The last question here asks you to describe the dot plot. So looking at that dot plot, it's definitely not symmetrical. What do you think? Well, we can sort of see here tail going in the negative direction. So I would say that it is negatively skewed. Stem and leaf plots are something that we use quite widely, and that's where we divide each of our values up into a stem and a leaf. Okay, so they're the two parts of our value, and this is how we're going to do it for this example. Let's have a look. For the following data, organise the data into an ordered stem and leaf plot. It is important that we always have it ordered. Now, we will use our calculator to order this data from smallest to largest to help us out. Now, it's really important that we do have our data in order in the stem and in the leaves. So you can see there that our smallest number appears to be 22. And our biggest number is 72. Our calculator will have these numbers all in order for us. So what we know, therefore, is that stems go from 2 through to 7 because it is the first part of the two-digit number. So 2, 3, 4, 5, 6, and 7. Okay, we must include every number. We can't leave out something even if it doesn't have a value in the original data. Now, our leaf also has to go in order. So reading from our calculator, we can see that the only value there that is in the 20s is 22. So that will go like that. Now, we're not putting commas in, and there's no other values with a stem of 2. So let's move down to our 30s. And if you have a look very closely, you can see that we've got 32, 33, and 35. So 32, 33, and 35. Notice I'm leaving nice gaps there, and I am trying to keep some columns happening here, and I've gone up in order. For the 40s, I have 43, 44, and 47. I'm lining them all up underneath each other, making nice columns again. 50s, I have 51, and I have 51 twice, and then I have 53, 57, and 59, and 60s, 62, 64, 64 again, and 68. And for the last one, I have 70 and 72. All right, now my stem is in order, my leaf is in order. You can see that I am lining up columns and rows. And if I was to turn that on its side, it would look like a histogram. You try that now. Does it look like a histogram? It almost looks like a symmetrical histogram to me. We've nearly finished our stem and leaf plot. The last thing that we need to do here is to put a key. A key tells you what the information is about. Okay, so here, it doesn't matter which number I take, 2/2 is equal to 22. So if I was putting exam marks there, I would put 22 marks. If it was percentages, I'd put 22%. That's obviously not going to happen for this one because this is just random data taken from somewhere else. So 2/2 means 22. And then it says describe the distribution of the data set as symmetrical as skewed. Well, we've just talked about that. Turn it on its side, looks like a histogram, and it looks like a symmetrical histogram. So my answer there is symmetrical. So stem and leaf plots are not difficult, but we must be very vigilant about the way we set it out. So the stem must be in order. The leaf must also be in order from smallest to largest, and we must make sure that they are lined up in columns, no commas, and don't forget your key. Back-to-back stem and leaf plots, so that's putting two stem and leaf plots with the one stem. help us when we are trying to compare data. So in this example, 2 television sales reps sell the following number of televisions each week over a 15-week period. So you have employee 1 and employee 2. Once again, we're going to put our data into our calculator and order it so that it's much easier to read off. But we can see straight away that the smallest number is in the tens and the biggest number is in the 50s. So our stem will go 1, 2, 3, 4 and 5. All right, now employee 1 we've put in order. So let's get going with that. So it goes 18 and 19, smallest to largest. And then for the 2s, we've got 0, 1, 3 and 7. So 0, 1, 3 and 7. And we keep going and fill out employee 1 the way that we usually do it. So again, you can see that we have gone from smallest to largest in our leaf, and all of our values are in columns. What about employee 2? How is that different? Well, it's not very different. We've got the same stem, and now we're also going to go smallest to largest, this time from the middle right out to the left. So let's have a look. What numbers have a stem of 1? And they are the 17s. So it is going to be 7 and 7. Okay, let's line them up in rows and columns. Okay, which ones have a stem of 2? Well, we've got 20, 28 and 29. So 20, 28 and 29. Now have a look at that. We're going from smallest to largest, but out in the other direction. Let's continue to fill that in. Our stem and leaf plot is nearly finished. So you can see that we've got 2 leaves with 1 shared stem. The last thing we need to do is put our key in. Now, we only need 1 key for the whole back-to-back stem and leaf plot. So I could use any of those numbers there, it wouldn't matter. So let's just use the last one, 5/8. And what is that standing for? That is standing for 58 what? 58 employees. So 58 employees. Describing our stem and leaf plot now. Well, there's 2 stem and leaf plots really. So let's start with employee 1. Turn it on its side and have a look at the histogram there. Would you call that symmetrical? I would. So employee 1 is symmetrical. What about employee 2? Is that also symmetrical? I think not. So here we've got something that is skewed, and because it's going towards the negative direction, I would say that that is negatively skewed. So there you have it, a back-to-back stem and leaf plot.